It is proposed as hypothesis the existence of a process linked to gravity. It would imply that the gravitational phenomena have associated additional effects which are not being taken into account by general relativity. These effects are negligible considering gravitational fields such as those corresponding to the Earth, but should be taken into account for stronger ones such as black holes. The physical phenomenon of gravity is even much more complex than what is being assumed by the already sophisticated standard model of relativity. The proposed process configures an imbricated setup of different factors, where matter, energy, spacetime, and probability are involved. The interactions that take place produce the alteration of matter and spacetime. General relativity already establishes links between matter, energy, and spacetime. There are many physical features that show these close relationships. For instance, the famous Einstein's equation is an example of the relationship between matter and energy. Another remarkable example is the way the space-time is curved by energy, or how this curved space-time defines the path that matter follows. The Einstein's field equations allow us to calculate that trajectory. The links between matter, energy, and spacetime show us glimpses of a much more complex phenomenon related to gravity. The proposal deepens into these interrelationships where each component plays a defined role and a new one is added, the probability. It has provided a new insight into the gravitational phenomena, which could help us see the whole picture. All the forces of nature but gravity have a mathematical model based on quantum mechanics. General relativity is the theory that best fits the observations concerning gravity. Meanwhile, electromagnetism, weak nuclear force, and strong nuclear force have mathematical models based on quantum mechanics. A fundamental feature of quantum mechanics is the probability associated with events. For example, we do not know with certainty if an electron is located in a particular region of space and time. Instead, there is a probability of finding the electron at a set time in a particular region of space. On the other hand, general relativity is a classical theory of waves in the sense that it does not have a probabilistic factor associated. After briefly describing the physical models used by scientists to explain the phenomena related to the fundamental forces of nature, it is time to introduce the proposed hypothesis. It will be schematically explained how the process works. To begin with, it is represented the probability associated with the particle. For example, an electron. The bigger the green circle, the higher the probability of finding the electron in that elemental region of space. Previously, it has been stated that the interactions caused by the presence of gravitational fields produce alteration of matter and space-time. In this way, let us first see the effects on matter. The interactions change the physical state of the particle, calling alpha state to the initial state, represented by a green circle, and beta state to the altered one, red circle. The interactions taking place reduce the probability that the particle is in the alpha state, while increasing the probability of being in the beta state. Now we can ask the following questions. Which are the physical consequences of that alteration? What are the differences between a particle being in the alpha or the beta state? In order to answer these questions, it is necessary to introduce another element, the spacetime. General relativity is based on a four-dimensional framework called spacetime, with three spatial dimensions plus the one corresponding with time, where time is transformed artificially into a pseudo-fourth spatial dimension in order to create the spacetime framework. In this way, the metric is defined, which induces the trajectory that a test particle would follow. Einstein's field equations allow us to obtain this metric. Spacetime is curved by the gravitational phenomena, with an interrelation between the spatial coordinates and the time coordinate. The hypothesis postulates that the four-dimensional framework configured by the three spatial dimensions plus the fourth dimension, which is linked to time. It is really a true genuine four-spatial dimensional framework. Furthermore, the process that produces the alteration of matter is what produces the alteration of space. Matter in the alpha state is linked to the three conventional dimensions, meanwhile, matter in the beta state is linked to the fourth. And that is the reason for the interrelation among the four dimensions, because the last one is generated at the expense of the other three. The Einstein's field equations provide information about the alteration of matter for any given coordinate. The equations, as defined in the standard model of relativity, are partially the transposition of the physical phenomenon that takes place. Because there are additional effects which are not being taken into account. As will be explained later, it has obtained additional matter besides, and associated to it, there is an energy component that must also be incorporated into the model. The interactions due to the proposed process reduce the probability of a particle in the alpha state, which is linked to the three conventional dimensions. If this happens with everything located within that region of space, and assuming that what is inside is responsible of shaping the space, then the space on that region, corresponding to the three conventional dimensions, is contracting. Noting in this way that a relationship between matter and space has been established. Matter and everything inside a region of space shapes the space. If we consider a gravitational field, like the one corresponding to the Earth, the closer to the source, the stronger the effect. The closer an object is to the surface of the Earth, the greater the amount of mass in the beta state linked to the object. And there is a correspondence between the alteration of matter and the curvature established by the Einstein's field equations. Until now, from a practical point of view, the proposal has only changed a criterion when it has been postulated, a four-spatial dimensional framework. But what about the time dimension? Considering a distortion of the time dimension in the same proportion as the distortion of the fourth spatial one, then the value of the mass in the alpha state and its fundamental features are restored. But now in a curved spacetime which has the curvature defined by general relativity, with some nuances. To begin with, added to the initial mass, called here matter in the alpha state, there is matter in the beta state, which has an extremely small value for the gravitational field of the Earth. It would be less than 1 grain for an object of 1 trillion tons, but the proportion would be higher if the object is located in a region where the gravitational field is stronger, for example, close to the Sun, and would be a lot much higher if located close to a black hole. Another issue to keep in mind is that the value of the mass depends on the reference taken. Although the standard model of general relativity has no such characteristic for gravitational fields, it does so when it comes to the special relativity scenario. There is a relativistic mass defined by Einstein, which depends on the reference taken. And, as we will see later, the hypothesis, including the proposed process, matches perfectly the special relativity scenario. So far, it is proposed that gravitational fields disturb the probability associated with that event, producing its corresponding effect on the curvature of the four-spatial dimensional framework represented here by 4 arbitrary coordinates. And the distortion of time restores the initial value of probability, called alpha state, but now there is an additional component of probability, the beta state. What happens with the probabilities can be extrapolated to the mass of objects. From the initial mass, it is obtained the same mass value in the alpha state plus an additional amount in the beta state, having established a relation between the alteration that takes place and the curvature of space-time, where the change for any coordinate will depend on this alteration. That is to say, the proposed process produces the physical effect from which the metric emanates. for example, has its corresponding effect in the change associated with the Schwarzschild radial coordinate, where the closer to the source, the greater the alteration. Now, it is time to focus on the energy factor. Energy plays an important role in the proposed process. As we know, there is a relationship between matter and energy. The process increases the mass of an object by a factor greater than 1, although very close to 1 for gravitational fields, like the corresponding to the Earth. This increased value of mass has a higher value of energy associated. And now the question is, where does this increase in energy come from? In order to answer this question, it is necessary to analyze the special relativity scenario. As its name suggests, special relativity is a particular case of general relativity, which deals with the relativistic effects of objects moving with velocity relative to a reference. Kinetic energy is the energy associated with velocities. Energy has the quality of conversion into different types of energy. For example, chemical energy can be transformed into kinetic energy. But that conversion is not 100% effective, and there is always a waste of energy. The transformation of potential energy into kinetic energy was an essential factor in the Newtonian model of gravity. The energies also play an important role in the theory of general relativity, causing effects on the spacetime curvature. Relativity raises the concept of energy. Now, it is not just a factor producing alteration or movement in objects, even more than the effect in spacetime. The nature of the energy itself has been rebuilt. Relativity shows a close relationship between energy and matter. The hypothesis proposes that gravity produces the alteration of matter and spacetime, establishing a relationship between the alteration taking place and the curvature of spacetime. Another remarkable characteristic of the process is the increased value of matter resulting, and that value depends on the reference taken. All of them are very peculiar features, and we could get to the conclusion that the defined process is not part of nature because the universe we live in does not show such bizarre behavior, or maybe it really does. Regarding bodies with velocity relative to a reference, Einstein introduced the concept of relativistic mass, whose value depends on the frame of reference taken. And, when approaching special relativity, from the point of view of the proposal, the interpretation of this physical phenomenon is that, when kinetic energy is applied to an object, then the process is boosted. It must be taken into account that a pure special relativity scenario, in the absence of gravitational fields, is an idealized situation, since that would require an infinite distance from the sources of gravity. Therefore, and assuming that when an object gains kinetic energy, the process is reinforced, this implies that matter is further being altered with its corresponding space-time distortion. Applying the model established by the proposal to the special relativity scenario, on the basis that the physical effect of the kinetic energy corresponds to a boost in the process, which increases the amount of mass in the beta state, there is also an interrelation between the alteration of matter and the distortion of space. The Lorentz factor is determined by the process. This has important implications, because the factor would be a consequence of the interactions taking place. Once again, following the same pattern as in general relativity scenario, the greater the alteration into the beta state, the higher the distortion of time. Being the value of the energy associated with the beta state equal to the value of the kinetic energy, we might come to the conclusion that when a body is increasing its kinetic energy, in fact, what is happening is that it is gaining mass in the beta state, whose corresponding energy is what we call kinetic energy. The addition of mass in the beta state to the mass in the alpha state is what Einstein defined as the relativistic mass. It is schematically represented, the alteration of matter, and its relationship with the spacetime. The scheme includes the additional spatial dimension, extending the standard dimensional framework. it must be taken into account that a Minkowski space is required to represent geometrically the standard space-time framework for special relativity scenarios, and a Riemann space would be required for general relativity ones. Following the proposed model to study the phenomenon concerning special relativity, the very same mathematical results are obtained as with the standard model of relativity. It has been changed the criterion and the physical interpretation, but the model, including its extremely peculiar characteristics, fits the experimental observations. The proposal implies that the value of the mass depends on the reference taken, changing with velocity in the case of special relativity, and will depend on the curvature of the gravitational field when affected by them. That is to say, different velocities on a negligible gravitational field environment have associated variable values of mass, and different locations on a gravitational field with different curvatures, but forced in a static state, also have associated variable mass values. Simultaneity of velocity and the presence of gravitational fields configures a combination of both states. This will be the case of a free-falling body. As we know, an object in free fall is affected by two relativistic effects, one corresponding to the curvature of space-time. In the example, a massive body is the source of the gravitational field, and the other effect is due to the relativistic velocity, which is a consequence of the curvature as the object falls into the gravitational well. Therefore, the distortion of time and space, relative to a reference, is the result of combining both effects. Based on the proposal, it has been suggested that the kinetic energy could be considered as energy associated with mass in the beta state linked to the object, which is the result of the alteration produced by the proposed process. In this way, we can come to the conclusion that when energy is applied to an object so that it increases its velocity towards a reference, then a process of creation of mass in the beta state is taking place. On the other hand, when the energy is applied in the opposite direction, it has the negative effect of annihilation. All in all, it is proposed a quantum creation and annihilation process of particles and antiparticles. The energy linked to the creation of particles is offset by the energy associated with the annihilation. Both have the same absolute value, but the first one is positive and the other negative. In this way, the increment of energy related to space-time curvature is generated at the expense of the negative energy linked to relativistic velocity. The kinetic energy, in this case, is not due to the conversion or transfer of energies. Therefore, the object does not accelerate. Nonetheless, it produces time dilation and length contraction in relation to frames of reference with relativistic velocity. This approach is consistent with the theory of general relativity. But now, there is additional mass, which is not being taken into account by the standard model of relativity. And the value of this mass depends on the curvature of the object space-time region relative to the curvature of the reference. As the object moves through a gravitational field, it is being affected by the described process of creation and annihilation. The alteration affects its mass with the corresponding spacetime curvature. If kinetic energy is applied with respect to a reference, then the process is boosted, increasing the amount of mass in the beta state. If the kinetic energy is reduced in relation to the reference, then the amount of mass in the beta state is reduced with respect to the reference. In this way, from the point of view of the proposal, the transfer of kinetic energy, which takes place when one object hits another, increases with respect to the reference at rest the amount of mass in the beta state in the second object at the expense of reducing it in the first. Thus, a parallelism can be established with the action-reaction effect. It has to be noted how this situation differs from that of the object traveling through different space-time curvatures of a gravitational field. Back to the free fall scenario. The kinetic energy of the object at the velocity expected by the standard model exceeds the value of the available kinetic energy. So, for the process to take place, it is required the conversion of a partial quantity of energy linked to velocity into energy linked to the mass of the object. That is to say, having established that the kinetic energy linked to the velocity of an object corresponds to the value of the mass that has been altered into the beta state, and assuming that the gravitational field produces two types of alteration, one corresponding to the curvature and the other to velocity. Then, the first one is generated at the expense of a partial value of the second. Or equivalently, it is an endothermic process, in the sense that takes energy from the physical system, taking place at the expense of the velocity term, producing the effect of energy opposed to the free fall. If this is proved to be true, then gravity would recover the status of a force lost in the standard model of relativity, but surprisingly, would be as a force opposed to the free fall, producing a counter-effect on the distortion of any coordinate. By comparing the effect produced by the process to the free fall scenario of the standard model, we would conclude that gravity is increasing the energy required to confine a particle within a region of space. Quantum mechanics rules establish the energy requirement in order to confine a particle within a region of space. The energy required increases the smaller the region. General relativity indicates that when there is matter inside a region of space, the particle is affected by space-time curvature, but not force effect is being produced. The effect due to the proposed process implies that complementary to the space-time curvature, the presence of matter further increases the energy required to confine the particle. From the point of view of the Newtonian model, we would say that not all potential energy is transformed into kinetic energy linked to velocity. The process that takes place prevents a total conversion. This would be an inherent characteristic of nature. Discrepancies between the geodesic defined by the standard model and the proposed one are bigger the closer to the source of the gravitational field, and the stronger it is. The graph represents free fall velocities. Black lines correspond to the standard model, red ones to the proposal. The closer to the left side, the closer to the surface of the sphere, source of the gravitational field. The bigger the factor linked to the sphere, the stronger is the gravitational field generated. Therefore, we have the scenario of general relativity. It is represented the probability associated with a particle, located in a space-time region, very far from the effects of gravitational fields, and the very same particle, changing its location, being now near the source. We must take into account the reference taken, for example the corresponding with negligible effects, or any other closer to the source. On the other hand, it is represented the proposal, where the effects are due to the factors previously described, which are interrelated, and the process is responsible for them. The additional probability is generated at the expense of energy opposed to the free fall. Instead of using the notation for the probability of a particle, it can be expressed with a wave function, which collects its physical state. Matter, energy, space-time, and probability are involved in a process where gravitational fields do alter the physical state of matter. The curvature of space-time is linked to this alteration. The energy requirement, as an effect opposed to the free fall, which might seem like an amazing result, but a fundamental feature of quantum mechanics is the energy requirement to confine a particle. Some physical phenomena of nature show very peculiar characteristics, in line with what would be expected if a universe behaves according to the rules defined by the proposed process. For example, the relativistic mass corresponding to special relativity, or time dilation in the same proportion than length contraction, which would be due to the alteration of matter to the beta state at the expense of the alpha state. Kaluza already proposed a fifth dimension 100 years ago as a possible way to combine gravity and electromagnetism. The approach taken here is different from that of Kaluza-Klein. instead of adding a spatial dimension to the space-time framework and considering the fifth one as compactified, which would be the reason for us to be unaware of it. The proposal postulates that what is considered to be the space-time framework, where time is transformed into a spatial one, it is in fact a genuine four-spatial framework. The movement of an object in what we call the space-time framework is nothing other than the movement in four spatial dimensions. And the proposal postulates time has the fifth dimension, where the alteration of time is the same than the alteration of the fourth spatial one, where each dimension plays an specific physical role, the three conventional, the additional fourth, and the one corresponding with time. If the additional dimension is not compactified, why do not we see it? And why do we not perceive the additional matter either? We do not detect them directly, due to relativity, because the values depend on the reference taken. But we would indirectly detect the effects of the proposed process. Below, it is exposed a practical example, with the aim of explaining all these issues. Two twin brothers are conducting experiments in laboratories. For example, the probability linked to the decay of a radioactive material after a set period of time. Each brother has his own time controller. It might be an atomic clock or any other like an hourglass. It is just a way of representing the rate of time that passes. What is the same for both, since their laboratories are located in regions with the same space-time curvature? If they are instead located in different regions, for example, one on the top of a mountain and the other at sea level, then they experience a different evolution of time, although, in this case, it would be very slight. Concerning special relativity scenarios, if a laboratory of brother B is inside a truck that moves with velocity in relation to brother A, each one will observe time dilation and length contraction in the other laboratory. These relativistic phenomena have been tested experimentally, in different ways, for example with an airplane. Basically, this is how relativity works, based on the model developed by Einstein. From the point of view of the proposal, the interpretation of this phenomenon is as follows. The interactions taking place produce alteration of the matter and the space-time framework configuration. So that, if we apply energy to the laboratory of twin B, in order to get it moving with velocity close to the speed of light relative to twin A, then this one will observe that the time rate in his brother's laboratory passes more slowly. In this way, the results of the laboratory B to reach the same values of probability will take longer from the point of view of twin A than the ones realized in his laboratory. Or, we could say that the alteration of the probabilities is the cause of the dilation of time. But what about the observations realized by twin B in his own laboratory? The change in the interactions with respect to the physical state when it was at rest with his brother produces the alteration of the radioactive material. But this very same alteration is occurring in the atomic clock or in any other time controller that he uses to count the passage of time. So that, from his point of view, just analyzing what is happening inside his laboratory, nothing has changed, either at rest or with velocity relative to a previous physical state which configures a different frame of reference. This phenomenon of dependence on the reference taken also applies to spatial dimensions. There is length contraction in the direction of movement, and the measurements patterns change relative to a frame of reference, as the physical state is altered due to different interaction situations. Twin A will observe length contraction in laboratory B, but twin B is unaware of any change in his own laboratory. It is only when there is exchange of information or interactions with other frames of references that he realizes the disagreement between both physical states. Similarly, when considering the mass of objects, there is a relativistic mass, whose value depends on the frame of reference taken. It has to be noted, the interrelation established by the proposal between space-time and matter. While, from the point of view of twin A, there is an alteration of space-time and matter in the laboratory B, his brother does not perceive any alteration in his own frame of reference. the adaptation to the new frame of reference would be the reason not to perceive directly neither the fourth spatial dimension nor the additional mass, but we would indirectly detect its effects when contrasting our frame of reference with others. As previously stated, this approach does not modify the expected results concerning special relativity scenarios. Discrepancies arise considering gravitational field scenarios, but it has required very strong ones in order to obtain important discrepancies. A free-falling person would be unaware of any significant change in matter and space-time in a local range around him. The shorter the range, the smaller the change will be. So, he is unaware of the fourth spatial dimension and of the additional matter. But when he sees the whole picture, then he realizes that the space-time is curved relative to other references. In this way, we only detect indirectly the effects of the altered matter in a fourth spatial dimensional framework. For example, we can see light bending when passing close to a massive body, like the Sun. And what about the additional matter? It would have not a significant effect on gravitational fields, such as the corresponding to the Earth or the Sun. But four stronger ones should be taken into account, and indeed, science requires the presence of dark matter in the universe, which has not been directly identified or detected, in order to explain certain gravitational phenomena. Therefore, the movement of a body in what we call the space-time framework is in fact the movement in a four-spatial dimensional framework which is curved by gravity. The trajectory is represented schematically. It might be calculated using general relativity, including the effects previously described, where we must add the time dimension, which runs inexorably. And the alteration of time is the same as the corresponding to the fourth spatial dimension. So it can mislead us, coming to the conclusion that the body is moving in a fourth space-time dimensional framework, when in fact is moving in a fourth spatial one, plus time. So that the general relativity model is overlapping the fourth spatial dimension with time. The process predicts the requirement of energy in order to follow the geodesic corresponding to the standard model, having an infinite value at the event horizon of a black hole, which would be a relevant factor to take into account in the black hole information loss paradox developed by Stephen Hawking. Noting as well his work proposing the creation of particles and antiparticles in the vicinity of the event horizon and its implications on the black holes. Another prediction of the proposal is the existence of additional matter whose value depends on the reference taken. For example, the matter corresponding to a black hole located in the center of a galaxy would be greater for the outer stars. It extends to gravitational fields, the concept of relativistic mass, introduced by Einstein. The universe remains an unknown territory. Science has detected gravitational effects, which cannot be explained by the presence of known ordinary matter. It has required the presence of unidentified matter, called dark matter, to fit the observations. The universe has less than 5% of ordinary matter. It is composed mainly of dark energy and dark matter. The scientific community considers dark matter as responsible for higher than expected velocities for the outer stars of galaxies. It has been proposed a process linked to gravity, which produces very peculiar effects. Could it be the cause of some of the observed physical phenomena that are still under discussion?